In this video, we will go over how to do hyperparameter tuning in Python. So let's get started by importing the necessary libraries here. We'll load a dataset, the breast cancer dataset, which has around 30 features, and it labels it has having cancer or not having cancer, as benign or malignant. And then here we split the dataset into the input and the output, and then we split it again into training and testing datasets, and we chose a 20% split. We then, after splitting it, we normalize the data. We're going to use a standard scaler, so we need to know the mean and the standard deviation of the dataset. When you do this, you have to ensure that you're only applying the fit command using the training data, not the test data or the combined total data. Okay, so the fit will only find the mean and standard deviation using the training data. After that, you can transform both the training data and the test data. This will ensure all your columns are in the same scale. So you can see we went from 20s and then 1000s over here to all between -1 to 1. Okay, or roughly -1 to 1. And we can then look at the correlation of the columns with each other. Here a high value means highly correlated. So you can see a lot of regions in this where we have highly correlated features which are contain redundant information. So we can do some kind of feature selection or feature reduction. So PCA is one such method to reduce the number of features. So we initialize the PCA here. Again, we fit and transform using the training data. So data normalized comes from here. Okay, it's only based on the training data. And you can, so here this step does both the fit and transform in one line. Okay, it's the same as doing the fit first and then transform. And after you do a fit and transform of your training data, you can do the transform for your testing data. And then here I'm plotting the explained variance. So it shows you how much is the variance in each of the principal components. So we started with 30 features. So you will have 30 principal components, and they are sorted in the order of explained variance. Okay, so the first principal component explains the largest variance, has the largest variance, and then it drops after that. So here I plotted the cumulative explained variance as well. So you can see after selecting maybe about 10 features, you reach close to 100%, so 90 some percent. So it makes sense to drop every other principal component after 10, for example. So we could then initialize an algorithm to do the classification. So the support vector machine classifier. Let's run this. You can then use the training data set, which has been normalized, and we also transformed it using PCA and fit the model. And then you can check the training score. Okay, so that's a 98.5%. Now this usually is not a good indicator, so you'll have to test it with your holdout data that you split in the initial stages. Again, this has been normalized and the PC has been applied as well. So let's check. So 94, so that's not bad. So it's a pretty good model as of now. So let's now see if we can do a hyperparameter tuning. But we can see that our machine learning steps are like spread across multiple cells. So we do, for example, a normalization here, then we do a PCA, and then we do the SVC algorithm. You can combine all these steps into like a single custom model using pipelines. So in order to build a pipeline, you import the pipeline from sklearn. So let's do that here. And then you can create a custom model saying pipeline, and then in order of the steps, you just define each step. Okay, so you give it a tuple in which the first input is the name you're giving to that particular step, and then which method is being applied in that step. So I'm going to do my scaling first. So standard scaler here. I initialize the standard scaler here. Then I apply PCA here's my PCA, and then I apply my classification algorithm, SVC. Now all I need to do is to run this. So it has been built. Now I can train it by just calling the custom model. So custom model, I can provide it with my X train data and Y train data. Okay, notice this is not the normalized version. This is not the one that PC has been applied to. It's the original raw data. Okay, the one that we split right in the beginning. Okay, so the raw data, we just split it here because the normalization and transformation into PCs happen within the pipeline. And you can run this, and you can also see like a preview of your pipeline, so you can see the different methods that's being applied to your data. Okay, let's check the score. Now the score should be the same as what you got here. So on the test data, you get the same score. Now we would like to change some parameters. So maybe for PCA, you don't want to keep all the features. Right now, all the features all the principal components are being kept. You don't want to keep all of them. In SVC as well, there are a couple of options that you can play with, some hyperparameters that you can change. So to do that, first we need to import the grid search cross-validation function from sklearn. Then we need to provide a parameter space to search in. Okay, so I'm gonna call this variable parameter grid, and within it I'll tell my grid search algorithm that these are the parameters that it needs to change. Okay, so in SVC, for example, you go back here and press Shift Tab, you can see the different parameters that SVC has. So one of them is C, and the other one is kernel, and you can read on the different kernels that you can try. Okay, so we're going to try linear and RBF, and we're going to try different values for C and see which one works for our system. For principal component, again, press Shift Tab inside the bracket, or you can also get this information by doing a question mark PCA. Run this, and it will initialize this the help documentation. So you can see there are some parameters that you can change. One of the most important one is the number of components to retain. So you can choose how many principal components to keep. Okay, so these are the three things that we're going to change. So we want to change the number of components. So you have to write it like this. You have to give it the step name PCA that comes from here. Okay, this could have been like my PCA. So this is the name that you gave to that step. So you can get this name, and then you have to write double underscore, and then the name of the hyperparameter that you want to change. So number of components, this is what I want to change. And for this, I want to have a range of numbers. So range is a function, so you can't see the result. You have to convert it to a list. You can enclose it in a list. So it goes from 1 all the way to 20 in steps of 2. Okay. Yeah, we could have done 2. Let's do in odd even numbers. And SVC. So now SVC has 2 parameters. So we're gonna write the step name. Again, this is not the function. This is the name given to the step. Okay. So you write SVC double underscore and then the parameter. So I write C to change the C value, 4 different choices, and kernel 2 different choices. Okay, linear and RBF. Now to run it, you just initialize your grid search, give it the model that you want to train on, and the parameter grid. And then you will tell it how many folds are there in your cross-validation step. So I choose 5 here. And after you initialize this grid search object, you can fit it using the raw data that you have. So in this case, it's going to do cross-validation. So I'll probably give it the entire data set and then let it train on the entire data set. And let's see how well it does. Okay, we need to run this first. Again, grid search is searching the entire space, so it's a combinatorics problem which will take a while to run depending on how complex it gets. So this one ran and we got like a 97.7% accuracy. Okay, so it has improved from 94 to 97, and this is again the average score. So if you want to see the result at each of the iteration, you can run the CV underscore results attribute, And this will show you in the order of, so you can see we have run 72 different combinations, and the accuracy ranges from 0.62 all the way to like 0.97. Okay. Okay, I hope this was helpful. You can explore more options within each of these methods. Right. Thank you.